today we're going to be going ahead and showing you guys how we could grab histograms and construct a table at the same time using a web calculator, and with the whole process of understanding how to make upper lower limits and non-upper limits and boundaries for the most part, depending on which book or class you're teaching or you're in from. So we will show how to adjust the calculator, put it into the data, and go ahead and construct everything that's up there. So we're going to be constructing a frequency distribution table, drawing a histogram, and it corresponds with it. And that's what we'll be seeing. Okay. Let's go and get started. So come over here. Our job is we're going to be pretty much making a distribution table that shows the distribution of the driving time to work of employees in minutes. So usually what happens over here that tells, oh, have some amount of classes. We're not doing that. There's a formula to doing those. Over here it says what if you already have found the convenient class width and convenient class size. In a lower limit. Okay. So what is considered a convenient lower limit? Well, a convenient limit is any value that either equals to or is less than the minimum value of the data. That's first and foremost. And we can definitely see over here that in this region, our data digits are min. 11 is the min. While at the same time, if you look and find the maximum, it happens to be 84. So when we're talking about the lower limit, it's the most convenient, it's the convenient one that that's going to ensure that we contain the minimum inside the first interval that we're going to be drawing on the grid. And the last interval that we're going to be pretty much drawing and writing out should consist of the maximum. That is the ultimate rule and requirement when it comes to making this table. Now these guys can make it they want to be. Just for us, we're going to do this, but you have to choose whatever it is convenient to you if you have to make a specific amount of classes. Okay, so we found this out. So we could just go ahead and start making the lower limits and then the corresponding upper limits, and I'll talk about real limits at the same time as well as boundary points, depending on which book you have. It will either be based on real limits or be based on boundary points. So let's go ahead and do that real quick. So we're definitely saying that we should be starting. We're supposed to be starting at the lowest lower limit, the first lower limit, which is 10. So we're going to write 10 here. And we're going to use the corresponding upper class width, which is 15, to build on. So come over here, we're going to have our 15, plus 15, that goes here. And when we add it, we're going to come to see that it's going to become 25. And repeat the process again, plus 15, we're going to end up getting 40. And we'll keep pressing 15 over and over again, and therefore we'll just be ending up with lower. I would say, okay, we can do it by hand, but that could itself take some time in regards to how fast you add or subtract. But just keep doing it in your calculator too. And I'll show you how the calculator works in regards to doing this continuous operation or the same process. So I'm going to turn it on. Get out there by just pressing second quit. Any operation program you're doing, you always end it by pressing second quit. So let's go ahead and throw out this. I did this last night, but I'm going to clear everything. But if you're in the previous line, all it is going to delete or clear that one region. If we want to clear everything, we go to the bottom where it's empty space and clear, and it clears the whole slate. So now you can't begin to do things back. So watch out for that. So if I come over here, we can go ahead and put the 10, and I can add 15, like I did recently, and that's how I got 25. And so it's making sense. It's agreeing with what we're trying to accomplish here. So plus another 15, and that gives 40. Nice. So that goes continue. No, I can plus 15. You don't have to necessarily do that. What you could do is the calculator always remember the operation you did if you get any type of plus with answer. So if I just press enter, it's going to keep repeating the same process that you want to repeat. I'll repeat. I'll continue to repeat until you tell me not to repeat no more. So come over here, we're ending up with something nice and interesting. So coming over here, we could go ahead and put up in here 55, followed by 70, and 70, and we have our 85. We're going to find something very interesting about your 85. So we're not going to have to make it for that guy, but it's going to be what we're going to refer to as the upper limit of the final interval. Because what we're seeing here is between 70 and 85, which are the real limits, the maximum is in it. So that means that we're pretty much stopping in an interval that we can say 70. So how do we find the upper limits? They're not the real upper limits, they're not, but they're a number that represents the upper limit. All we're doing is going 1 less than 85. So we're always going 1 less to bring down. So 1 less than 85 is 84. Okay. 1 less than 70 is 69. 1 less than 55 is 54. 1 less than 40 is 29. 1 less than 25 is 24. Oh, this was 39. 39. And we pretty much have our upper limits. Remember, once again, these are not your real upper limits. These are just your upper limits that were used to describe the interval. So what are our real limits? So over here, when I write RS, I mean real limit. So when I'm referring to real limit, I'll be referred to as RS. And when I refer to boundary point, I'm referring to, I'll be writing B. And this will be consistent or L for lower limit. Where we got S from. But anyways, come to that. Over here, I'll be writing my real limits, R L. So real limits is pretty much how we put the lower limits. Let's go lower limit to lower limit. Those are the real limits. If anything that's in this lower limit should be going to this interval no matter what. Anything less than 40, which is this class's lower limit, should be going to the previous interval no matter what. So come over here, we know the real limit is going to be pretty much 10 to 24, followed by 25 to 25. 25 to 40, 40 to 50, 55, keep messing up there, 55, 55 to 70, and 70 to 85. So these are still real limits because all we're saying here is we're going for anything from 10 to 25, but not anything equal to 25. So that's the lower limit of the next class. That's where the next class should be starting, no matter what, or interval. So that's what we're getting at here. So interval and classes always go to the measurement that we're looking at here. The measurement, the values that we measured always goes there. This isn't anywhere else, so we could write up here. This is permanent to our class / interval. I used to write interval when we have more than a range like this, range of values, where our classes could just be a single value like 10. That'd be a class. So interval. Let that out the way. So the question is, how do I find the boundary points? So depending on what class you're in, boundary points will be key. But it turns out the boundary points are points that are halfway between the upper limits that we made for the interval and the real upper limit that corresponds to it. So when we go halfway between 24 and 25, we're going to end up getting 24. And I've put here B, P. So when we do this, we're going to end up with 24.5. Same thing is consistent over here. Halfway between 39 and 40 is 39.5. One thing you might notice, if we're looking at this pattern, we're kind of noticing over here that halfway between 1 is 0.5. Okay? Halfway between 0.1 would have been 0.05. So we're kind of seeing a pattern. We're seeing a pattern here. So 0.5 above the upper limit or 0.5 below the lower limit, and both meet in the same spot. So pretty much I put one halfway between plus 0.5 to 54, giving us 54.5. And repeat the same process over and over again. Over here should be 69.5, followed by 84.5. So we have to go outside the boundary too, because remember, these are real limits. We have to place the real limits with the boundary points. That's what we're going to do. So over here, all we know is that when it comes to this real limit, we're saying that for the real limits for the boundary points for from 87 to 84 is going to be half to the left of these guys. So this is real limit, while boundary point that corresponds with it happens to be, in this case, 69.5 to 84.5. Those are the boundary points for the last interval. So we have to make sure that we do the same thing on top. There has to be a boundary point that corresponds with this real limit. So if we go halfway down, we're looking literally at 9.5. Because if you notice, what would have been the next upper limit? It would have been 9. Okay, we just go one less. So therefore, so we know that the first interval would have been the corresponding boundary point that goes with it. Well, it would have been literally 9.5 to 24.5, which is just halfway down from each one. So you go halfway down to match up with the real limits, and you're done. So depending on what book you have or the teacher you have, either you might be graphing using these guys, or you'll be graphing using these guys. And the midpoint will correspond to whichever it is that you're using as your limits. But anyways, come on here. Now we could look to see the frequency, how we obtain the frequency distribution, and get the rest of it. So now we set the table, so now we can actually get things done. So this right here helps us actually set up the histogram, or a polygon that we're going to be graphing. So we're going to keep note of the lower limit, we're going to keep note of the upper limit, and we're going to keep note of the interval width. And then from there we could expand them when necessary, keeping consistent. That's the most important thing that we want to keep consistent. So how do I do this? Well, first thing first, we're going to go over here to statistics, because statistics is where we put our data and calculations. Everything's under stats. So we hit stat. So now you're getting calculations or tests. This is for later on. We'll be calculating and testing hypothesis and getting intervals. We're here in edit, because this is where we actually edit the data. We have any data. So this will be sort when we need to sort from least to greatest or from greatest to least. But usually least to greatest will be the one we're doing. But we're going to edit. To edit where we actually sort our list. So notice I already have lists already in here that I'm not getting rid of. So how do we get rid of things for right now? Well, we get rid of things by deleting, go to the list title, but make sure it's highlighted. So notice how it's highlighted. And you can see the list in the bottom right here. That means that the whole list is highlighted. So now I can press clear and enter. Oops. Delete. I messed up. Clear. Then enter. So now you see everything disappeared. So I'm going to keep doing the same thing until I get to list 1. I'm going to keep this one so we can see how to insert and delete when necessary. So over here, I'm going to clear, and just go here, clear. If you already have it clear for yours, it's okay. This is how we actually clear content, if you need to. So over here we have 1. So let's just say that, oh crap, over here it wasn't supposed to be 40. So it's supposed to be a different number. If that's the case and you just mess up with the number, you can always readjust this by highlighting it and just typing in what it was supposed to be. You say, oh, it was supposed to be 73. So now it's 73, and I can enter it, and it replaces it. Okay, so that's if you accidentally might have typed in something wrong. But let's say, oh, wait a second, 73 wasn't even supposed to be in the data in the first place. Or that 40 was supposed to be in the data in the first place. How can I delete it? Well, we have a delete button right here. So when we press delete, what happens? We delete that edit. So what if things go wrong and say, oh wait, we found later on that, oh, that 40 was supposed to come back, I messed up. I didn't realize that the 40 was supposed to be there in the first place. So how can we bring these back? How can we insert? That's the most thing, because I still want 40 to be between 25 and 50. That's what I want 40 to be. So how do I do this? Well, I'll go to 50 where it's supposed to be in the next down line. And I want to press second insert. Because insert is opposite delete. Okay? So therefore, we put insert. And now, notice how it becomes a 0. It says, okay, I'm inserting 0 until you say otherwise. So at that 0, I'm going to go ahead and type in 40. I'm sorry. 40. And enter, and it's now back. That's how you pretty much change the number, delete a number, or even insert a number if things goes wrong. Recipes refer to data here, because this is actually data that we're getting from the table or something. But anyways, now I'm going to clear the whole thing off by going to the L1, make sure that the list is showing right here, which implies that I have to delete it. By clearing and pressing enter. Wherever you don't press delete, you press delete, the whole list deletes and it's off from the system until we learn how to bring it back. But we don't want to do that. So at this time, what I want you to do is let's go ahead and insert the data that goes to the variable of time, driving time to work. So you can either go down this way or this way, whichever is easier on your mind or in your eyesight. I'm going to go this way, but you can go down this way if you want. Just make sure each data is accounted for and we don't mess up with the inputting. That's called data entry error, and you want to avoid that. So let's go ahead and do that. So I'm going to put 32 first. Enter. 22. Enter. Or you can just press down. It also works. So if we do 11 and I press down, it also works. So it's your choice of how you want to enter and get to the next line. 47. Enter. 20. Enter. 27. Enter. 40. Enter. 65. Enter. 18. Enter. 25. Enter. 35. Enter. 54. Enter. 21. Enter. 30. Enter. 84. Enter. 20. Enter. 25. 25. Enter. 38. Enter. And 58. Enter. What we're definitely noticing here is I'm at L20 and notice I have a blank. So, and when I actually count this, it's supposed to be 20. If I have 5 across and 5 down, so I'm supposed to have total number 20. My N should be 20 observations. However, when I look at mine, 20 is blank. The last observation I'm seeing up there is 58, okay, which is at 19. So that means that I have to have missed something. Let me see what I have missed. So I'm going to the very top and relook at what I might have done wrong. So 32 is there, 22 is there, 11 is there, 47 is there, 20 is there, 27 is there, 40 is there, 65 is there, 18 is there, 25 is there, 35 is there, 54 is there, 21 is there, 30 is there. Oh, there it is. I'm missing this 43. Notice that. I went from 30 to 48. So how do I get this guy to get in there? Once again, like I said before, if I need to put it in the order in which it's supposed to be, I'm going to go to 84, which is where it's supposed to have been in, and I'm going to do second and enter. It becomes a 0, which now means I can fill it in and make it 43. So now I enter it. Now it's in proper order, 38, 43, 84. Nice. Let me just make sure everything else is good. 20, 25 is there, 38 is there, the date is there. Now, if the date is a 20 value, in order to ID it. So make sure we put in in proper order. It doesn't matter for this one here, but it will matter to do frequencies, distributions, and correlations. Order will matter. So knowing how to insert and delete will be important, or replace. But anyways, we got that. So how can I find the max min without having to look at the data and do like a needle in a haystack? There's two ways of doing it. The quickest approach for now, it gives you a lot of information, but it works. You could go to stat, and you could go to calculate. And we're going to do one bar stats, because once again, we only see one variable. We're only seeing driving time to work. So this is just one variable, which is time. So we're only doing, so we should be just looking at highlighting one bar stats. I'm going to do this. It's going to say, okay, which one do you want to get it from? What list? Well, the list that contains the time is the one we want for. So the time was list 1. So, but if you need to get the list 1, how does that work? You press second and then 1. Because if you look over here, 1 is the second setup of 1. So you just need to do that. Frequency we leave blank. Don't touch that. Leave it the way it is. And over here we calculate. Frequency will change. We have tables, distribution tables. So now I can go to calculate and I'll enter it. So it does all the stats for me. We can see these stats in the future, but what we're seeing over here is all these guys right here. We're going to be seeing when we get into measure centers, measure variance, variability. And over here we have our min. Well, min x is 11, and it's matching to what we said before. Our min was 11. So we're getting the same thing. The Q1, the median, and the Q3 is going to be something we'll also be using for measure variances and box plots, but we're not there yet. And then we have max. Max x. Well, max is, the variable we're looking at here, is 84. So we're good. So is there another way we can do this? Yes. So we can technically put this so we just make sure we're out. So everything's here. This is done. That means it was completed. So now is an ultimatum. There is an ultimatum. And notice how we were looking at calculating from a list. So we could actually do this operation, which is right here. And that's second stats. So I could do second stats. And what I do here, we're not going to make any names. We can keep it the way they are. But we have operations that we're looking at. And we have math. So it'll be either in these two guys right here, depending on what kind of operation you want, or what kind of calculation you want to. So math, these are calculations. These, they were operations. Okay? So come over here, right there, notice for option 1 is min, while option 2 is max. So I could actually select option 1 by entering it, or pressing 1. And now I could call upon this one, because that's the one we were looking at, this one. So once again, this one is supposed to be second 1, which is here in the bottom. So I'm going to do second, and press 1. And I close the parentheses, just to make sure that it is on one group. And I enter it, and I get the same answer. That's amazing. So I can also do 9, max, the same way. So second list, go to math. Now I choose max, and I'll do the same thing. Second one to get the list 1, close the parentheses. And when I enter this, I'll get 84, and I call it the same way. So it's really up to you how you want to find the max and min. That's totally up to you. Okay. So now going further from here, what we're seeing is now how I'm going to get the histogram or the distribution to work from here. Now that we have this information, what we're going to do here is we're going to actually first and foremost, I'm just going to readjust the windows for right now to be what we're looking for. There is a quicker way. With this, I'll show that and show how it's not really that efficient and it's not going to equal what we want. So first thing first, I'm going to do second stat plot, which is right here, which is y equals. So I'm going to do second y equals. And notice I have a few graphs on. I don't want that. So you can come down here to plots, and you can turn off. And what it does, it will turn all plots off. So it says, oh, plots off. So when I go to second stats again, notice how they're still on. I'm supposed to turn all the plots off. But anyways, I I'll just do a manually for each one. So come over here. I want to keep this one on, but I'm going to go to plot 2. Notice how and go down. So now that on is flashing, I want to go to off flashing and press enter. So now when we press down, it is definitely off. So, and also on plot 3, I want to do the same thing. I want to go to plot 3. Selected. Crap. I'm going to do that. So back to second graph. I'm going to plot 3. Make sure, I'm going to plot 2 right now actually. Make sure it's off. Go to plot 3, have it selected. So, and make sure it's off. So remember, when you select things, make sure it's highlighted and you press enter. If you don't press enter, it's not going to select it. Keep that in mind. So plot 1, notice that I didn't turn it off because that was in plot 2. Make sure the on is selected, it's highlighted, and press enter to turn it on. So now, come over here to the histogram. The first option is actually a scatter plot, which we see now we get correlations. The second one is actually a XY line, which actually is used for cumulative frequencies and relative frequencies, for the most part. This one here is your histogram, so we're drawing the histograms. This will also be a bar graph in the future, depending on how you set up your scales and values or labeling. The second two to the last, these guys are 2 different types of black spots, where one identifies the outliers, but the other one just goes from min to max. And then the last one over here is pretty much the normal distribution plot, or normal plot, which right here is for us to figure out does it appear to be normal. And there's roots for that when we get to those. But anyways, I want to have the histogram highlighted, so therefore I'm going to make sure it's highlighted and I'll press enter to ensure that it works. Coming down here, notice over here I have this one, X values, or X values is supposed to be the measures we're looking at here, and our measures are in L1, all the measures we have. So we're going to keep that good. If you need to change it, just remember it's second at L1 in the bottom. Over here, frequency, we have nothing for L2, so no frequencies. So make sure that we change this and we make it a 1, okay? Or we just delete it. So we just delete it and keep it with frequency like that. And enter. Well, it's not allowed to, so we have to put 1. So make sure it's a 1 here, so it could adjust. And then over here for color, if you have color calculators, you could change the color to anything you want. That's your choice. Like do the multiple colors to represent multiple graphs or multiple data. So I'm keeping blue for right now because that was the default. And so up to here, I want a graph. Notice right here, I already had done some modification before. So this is what's happening. However, what's really happening here is it won't look at this most of the time. We will look at different graphs. So this will change over time. So how we could actually get something to work. To make a quick histogram that the calculator would think is the best for itself, we could just go to zoom and we can come over here and drop to 9, which says zoom stats. Right here, zoom stats. So when we enter this one selected, either press 9 or press enter on it, it does this. However, if you notice, it changed the graph to one had before. And we're going to notice a flaw to this. And the thing is, remember, the graph calculator made its own choice of what it thought was the best one. That's what it did. So what we're going to do is we're going to make sure that we have our interval. And I'll prove to you right now what I mean. So I'm going to hit trace right here, because that's how we can figure things out. I'm hit trace. And what we're clearly seeing over here, we're definitely seeing that min for the first interval, max for the first interval, which are supposed to be the real limits that are over here. Notice how we have 11 for the min. Over here saying min is 11, but it's supposed to be 10, because that's what our lower limit is over here, our real limit. And then our max is saying right here is saying 25.6, but our max, our upper limit was supposed to be 25. So notice how it's off, which could change the count because we're including things that are not supposed to be included. So what we're going to do here is, instead of having min to be 11, I want to make this guy to be our first lower limit or the first real lower limit. So this right here is supposed to become 10. So we're going to be fixing that. For this is min x. We're going to see that. So these are for the x values. So it'll be the x min and x max. We'll be seeing. And that's what the first thing we're going to be seeing. So we want to get that to become 10, and then we're going to erase that. I'm in the wrong spot. I'm thinking about something else. But that's what we're looking at. We want to get that to become 10, and obviously we want to get this here to become what we want to be the limit to be 25. We want to get that to happen. So let's go ahead and see how can we adjust this. So adjusting it, we're going to go to Windows because that's where we have control of everything. So notice that over here, the top one says max is 11. We don't want that to be 11. We want that, or no, sorry, the x min. We don't want that to be 11. We want that to be the first real limit. First lower real limit, which is supposed to be 10. So I'm going to put 10 there. Now, next one. So I have to put the maximum. Well, over here, for our sake, we're going to go for the last real limit at this time, and that's supposed to be 85. That's the one that gave us the last upper limit. So we're going to put the real limit 85 in there. And then the scale, the scale is supposed to be pretty much your task with your rectangles. So it's not supposed to be 14.6, it's actually supposed to be 15. So we're going to fix that. We're going to make that 15. And now going to the next ones down here, that will be changing when we get to different frequencies. But this time, the min, since we have to make sure that this axis right here is the y equals 0. So we have to make sure we can see the x-axis, so we're going to choose a value that's less than 0. But that's the negative is up there right now. But once again, we will cause we adjust it to be to our liking. So let's say I want to put negative 5 there. How would I do that? First thing first, in order for us to get negative 5 in the calculator, to get this result, it comes from first pressing the negative button, then rewrite 5. When we do this, it will give us the negative 5. So what's really saying here is, I want to multiply the negative number to positive 5, and that will give us negative 5 in return. And exactly what we do that naturally. So the negatives right there on the bottom of the equals is, it's pretty much right here. So I'm just going to bring it back down so we can see it happening. So I'll press negative, under one spot, offline, delete. Where it's supposed to be, which is at the negative 2 for the y min, I'm going to get negative 5, just for right now. And for y max, we could give a guesstimation to what it's supposed to be. If you don't figure it, we could figure it out. We don't know if we can do that. But looking over here, we only have 20. So I don't think we're going to get anything that's greater than 10. We need to rescale. We can always rescale. So I'm just going to put y max to be 10, so we can see what the guy is looking at. And the scale over here, I'm going to change that to 5 because it's going to do something pretty nasty. I'm going to see the scale on the side. I'm going to make this pretty much scale 2. For right now, it could be scale 1 if you choose to. But I'm going to do scale 2 so we can see something happen. So now I'm going to graph it. And there we go. You have a graph. So now this looks more efficient. Okay? And now what we're seeing here is, if I do trace again, press trace, we now get the min to be 10 that we want it to be, and the real upper limit to be 25. That's what we wanted. So therefore, now it's going to be consistent. So therefore, we're good. We have this, so it's going to go up to this guy at the end. And we'll see, and you can see that. So notice how over here is going by tens. So it's supposed to be by twos. So notice how over here, each of these hinges that you see up there are based off twos. So the last hinge on top is the fifth one up. And remember, that's supposed to be the maximum y value, which is 10. So just counting by 2. So 2, 4, 6, 8, 10 on top. So halfway between each of these scales, hinges, is supposed to be 1. So you can know what the halfway markers are and how those guys are working on the calculator. So we can definitely see over here, when we connect it to, well, I go 3 up here, it's going to be 6. And over here, we're definitely seeing n equals 6. That is our frequency that corresponds with the first interval. So we can definitely put over here 6 for frequency. Bam. Now we'll move over to the side and see something interesting happen. Over here, well, the lower limit is supposed to be 25 and the upper limit is supposed to be 40. It's matching here. That's nice. That's what we wanted. And also notice how when we look at the top, the 7 happens to be halfway between the 4, the 6, and the 8. So we're graphing it, that's what we're kind of looking at. And so we put 7 here. And remember the n that's right here, that is your frequency that corresponds to the interval. These are your real limits, these are your intervals. That's all it's saying. Next. Now we could go right again, and we get 4, and repeat the same thing, 2 and 1. So we know all the frequencies that correspond to it. We have the histogram, and we also have the frequency distribution at the exact same time. We hit 2 birds with 1 stone, which is very nice. Who would have thought that, right? Anyways, come over here. What we're going to get used to understanding is what is the x-axis, what's the y-axis when we're graphing and making grids. Notice how over here the x-axis dealt with the intervals, which makes sense. X value is supposed to be the scores that we're looking at, while the y values, that if you notice on the graph, was our frequencies. So the y-axis here should be our frequencies, and that's what we're seeing. And I'll write that right here. So over here, y-axis is frequency. And I tend to write F or EQ for short when I write frequencies. And then the bottom right here is supposed to be driving time. In minutes. So we have that situated. So now we're going to put the intervals in. Notice over here, it's a zoom in. Keep that in mind, it's zoomed in just to the histogram for where it starts and ends. So we're graphing it, we should be pretty much more outwards, because we can assume that this is your 0, or if we're going more outwards. So therefore, I could just say, okay, let this here be our lower limit, our lower limit, which is 10. And I can start building and getting all the other real limits that are there. So we have 25, 40, 55, 70, 85. Those are real limits. And notice how over here, I try to keep as consistent as possible, evenly spaced as possible. Even over here, it seems to be a little bit more wider, so I can adjust. That's why I have pencils, so you could adjust things. So we have that situated. Keep in mind, note that when I here, I just use the real limits, because I was keeping to the graph was doing. The graph on the calculator was using real limits. But depending on what you have, either it'll be real limits or it will be the boundary points. So what we're really seeing over here, if we were doing boundary points, instead of putting 10, what we would have here is 9.5. That's what we actually had there. And we're just getting the corresponding lower limit or corresponding boundary points for each real limit. So over here, 24.5. And once again, we're seeing it is just going halfway down, because we're in the ones. So over here, 39.5. Over here, 54.5. Over here would be pretty much 69.5 and 84.5, where we know that these are our boundary points. Well, these guys right here were our real limits. Okay, so it depends what you have and how they want you to get things done. So over here, notice that our highest frequency was 7, right? So we say, okay, well, how many grid lines do we have here? And it's going to help us on that. If it does, okay, we go with it. If it doesn't, we have to adjust our scaling to be more useful for us over here. So if you count, we have 1, 2, 3, 4, 5, 6, 7. It already makes it. But I'm going to go ahead and say, assume, hey, what if the 7 was here? What if it was 6? What would I have done? Because sometimes we don't know how much scales we have here, but we can always adjust our scales to our liking. So let's just say that, okay, the 6 exists, the 7 didn't exist. How can I rescale it? Well, if 1's not going to work, why do I do scales of 2? So that means over here, I could be writing first of all 0 in the bottom, then I'm going to jump 2, I'm going to jump 4, then 6, 8, 10, 12, and 14. So notice how I could readjust this grid so it could fit my histogram fit. So all we're seeing now is anything that's a half in between will be the odd number. So 1 was actually here, over here will be 3, and onwards. That's what we're seeing. Halfway in between will be the halfway marker. So now we can actually got this histogram to our liking, and I'll put that in green for now. Or actually, let's keep blue. So I could, not green. This is nice. So here we go. Therefore, from between 10 and 25, or the boundary point, it's supposed to have been 6. So I'll make sure I'm gonna get down quick because my angles is pretty horrible. And make sure it's as nice as possible. We can't make it perfect, but we can try to be as perfect as possible. So we got that in there because we don't want to make the graph misleading, so we try to make it as perfect as possible. And we know this frequency here was your 6, this round line. 7 happens to be between 8 and 6. So I know I have to go halfway. So now I could draw its rectangle connected from boundary to boundary or real limit to real limit. And this is your 7, the corresponding. The next one over was supposed to be 4. Well, 4 is right here on this line. So therefore, I could make its rectangle, we know it's 4, followed by over here, we're going to have 2. Well, 2 is on this line. So I could draw it here. I know that's 2. And 1 happens to be halfway between 0 and 2. So the halfway marker is where I'm going to go. And I'm going to say that as 1. So here's my histogram. Okay. You can shade it in if you want. But that's really your choice in the matter. Okay. So we have successfully made a histogram. So we got both a histogram and the frequency distribution at the exact same time, which is nice. Okay? So if you have a frequency distribution, you can literally figure out your histogram just by putting in the more information. And knowing what your lower limit and your intervals are. Which lower limit and interval covers the rest of it. Or classical, I mean. Anyways, so how does the polygon look like? This is your histogram. The green is your histogram. So I get to put here, green is our histogram. Okay. So I want to first draw a polygon in black. And we're going to say, okay, how are we getting it? How does the polygon work? A polygon gives the same distributed shape of the data as the histogram does. The only difference is instead of having connected rectangles, it's going to be points that are connected by a line, corresponding to the XY line. Right. So what we're saying here is, how do we figure this out? Well, the midpoint is supposed to be halfway between the interval. So if you're doing lower limit, or lower limits, it's halfway between the lower limits. If you're doing boundary points, it's halfway between. Okay? Somehow your book ends up doing upper limit, lower limit. It still works, but I tend to do this with the boundaries. So I find the midpoint, midway, and I know my point is going to be here. And a repeat process. Midpoint between these real limits or boundaries is supposed to be here, and a point corresponds right there. Between these midpoint, these real limits or boundaries, I get the midpoint, and I put the corresponding point at the frequency. And I repeat the same process every single time. So I'm graphing on the same grid. Usually it'll be graphed on different grids. I'm doing here because, once again, it becomes important to see how it's being made and how they relate to each other. So, but this is not it. We don't just do frequencies. We have to, for polygons are supposed to start at 0 and end at 0 to make somewhat of a mountain shape. So we have to make sure we get that to happen. So that how to do this means that we're actually really supposed to be starting one interval out. Okay. That's why when I do graph diagrams, I just go one interval out so that I can see where the midpoint goes. When I see my histogram, I can just say, okay, this is what polygon should look like, since I know what a histogram looks like. So come over here. I'll come over here and I'll put halfway marker over here. At least be a halfway marker right there. And over here it's supposed to be 0. And over here I continue, and where would have been over here, I would have the next one, so halfway of that is right here. So in here, I'm gonna put 0. So we have a midpoint before, one interval before the first interval, and a midpoint one interval after the last interval. And at those two midpoints, the frequency is supposed to be 0 because we want it to hit the x-axis. So now when we connect the lines as best as possible, okay, try to make it straight lines connected. I have a polygon that corresponds with the histogram. Notice how it's still representing the same shape of the distribution, just that we're representing with a different type of graph. So over here, I'll put in black is a polygon. Okay? So, we got that out of the way. Next. If that's the case, how can I put this into a calculator? Because remember, when if we're doing this by hand, we had to literally specify what our midpoints are and corresponding to the frequencies when we're doing them. That would promise me to work, so that you know, hey, I know what I'm doing. I know how polygon works based off the intervals that I have. I know how it really works. So how do we find a midpoint? Well, your book says don't look at the bottom part, just go with the intervals. I'd say, well,